Here's a brief explanation of one of the problem types in Chapter 11. This is the section on chi-square testing. And the idea here is to get a sense for how we compare the real data that we collect to the hypothetical data, or not data, but the hypothetical table that we would see if our two variables, our explanatory and response variables, are indeed independent, if there's no relationship between them. So the first thing is, in this problem, they're talking about political party identification and gender. We would normally think that gender would explain political party identification, that is, that your gender may influence which political party you choose. Your political party doesn't influence which gender you become. So right off the bat, we know that gender is the explanatory variable, and party identification should be the response variable. And we typically denote that by having the rows be the explanatory variable and the columns being the response variable. But it's not super important that we stick to that all the time. In B, the table that we get here, this is the solution. Notice how they're kind of prompting us by saying that these have to add up to 100%. So across here. So we need things that add up, that these three numbers should add up to 100%, these three numbers should add up to 100%. So the place they're getting those is by doing the, let's say the top left one here, this guy. That's coming from taking it's coming from finding the percentage of all females who are Democrats. So that's what this number is right here. The way we're calculating that, the way we can calculate that, is by, in our table, here's our data table up here, we need the percentage of all females. So we need to know how many females there are all together. And I forgot to add these up before I did this. Hang on a second, let me get a calculator. Okay, success. So the percentage of all females who are Democrats, the total number of females, if I've added numbers correctly, is 1,650. So that's the number of females. So percentage of all females would be 1,650 people. That's adding up these three numbers. That's how many females I have. And of those 1,650 people, 196 of them are Democrats. So that's the number right here. So that is the number that if you do the calculation, you'll find is 11.9%. Similarly, this number is also among females. So we're also dividing by 1,650 here. This number is going to be, just this up here. So this number is also going to be out of 1,650 because it's a number among females. But we want how many are independent. So there are 912 independents out of the 1,650 women that I asked, and so that number ends up being 55.3%. Just for another one, let's do the males here. So this number, this should be the percent of all males who are Republicans. And so, and we know how many males there are. And again, it's back to the calculator. There are 1,181 males in this particular problem. The total number of males is just the sum of these numbers. Of those 1,181 males, it tells us that 355 are Republicans, so 355 over 1,181. That's where this 30.1% comes from. So each of these percentages is just coming from the percentage of females who are in each party and the percentage of males who are in each party. Now, let's see. Oh, they do ask us, what do you think is going on with these conditional probabilities? And so they say females are more likely than males to be Democrats. That's true slightly. You can see that higher percentage of women are Democrats than men, and males are more likely than females to be independent. So males have a higher percentage of independence than females do. So these sentences are a little hard to read, but they're just asking for the comparison of the different percentages in this table. And one of them will be right and the other ones won't. Now they're asking about the hypothetical example. Now this is going to turn into, when we do our chi-squared test, this is going to turn into the null hypothesis, the hypothetical example of what this table should look like if the variables are independent. Well, if political party and gender have nothing to do with each other, then we would not expect to see any difference at all when we look at percentages among females and percentages among males. They're giving us this first row, and so all we have to know is that the second row should match the first row. These two rows should match. The percentages ought to be identical if gender and political party identification are independent. And so then later on, this is one of the early questions, but later on when we actually do the chi-squared test, the chi-squared statistic is actually measuring how close these two tables are to each other. It's saying how different these two things are. So chi-squared's job is to measure the difference between these two tables, and then based on sample size decide if that's a big difference or a small difference, and that will determine the outcome of our hypothesis test. But this is what it's trying to do.